I've been doing some stuff on radiation, the Earth's atmosphere and everything else, and I've come up with something that hasn't been looked at before. If you start just with the Van Allen belts and how they respond to radiation.
Sure.
There's 40,000 kilometers range there where the magnetic field, the band lines, are trapping the radiation as it's approaching the Earth, and you have that bow shock wave that's traveling around as the Earth is traveling through space, right? And that's all very well mapped and everything else. And of course, the closer the magnetic lines are to the Earth, the closer ones, the stronger they are. And eventually, at 1,000 kilometers out, the last band is there, and it successfully traps the very dangerous radiation. And the only thing coming through there after it's traveled through that 40,000 kilometers is just visible light or UV light coming through. And the only thing harmful to us, of course, is the UV light, and then the ozone layer is protecting us from that. But the same principles have to apply to the moon. The moon is traveling through space the same way. It doesn't have a protective magnetic field to block that radiation.
Yep.
It's going to be putting out its bow shock wave around it. If you think of a stone in a creek and the water passing by and the pressure builds up on the side and then bleeds off around it, the moon is doing the same thing, except it doesn't have 40,000 kilometers of bands to slow it down. So now it's even more concentrated when it hits the surface. Potentially, that 40,000 kilometers, its very first impact is the surface of the moon.
Right.
Now you have that radiation compressed into a smaller space.
Very concentrated area.
A lot higher.
Yeah. No, that's a very good point.
So whatever the readings are on the Van Allen belts, the radiation readings there, let's say they concentrate down for 5,000 kilometers off the surface of the moon. Now it's 8 times.
Sorry, you're talking 5,000 kilometers from the surface of the moon?
Yeah, let's say it's compressing down as it's hitting. It's gonna bleed off around the side, but it's building up. Now you have that concentration of radiation on the lunar surface.
Right.
Let's say it's 5,000 kilometers off the surface.
Right.
Right. It's 8 times the concentration of what's in the Van Allen belts around the Earth.
Yeah, that makes sense.
If it's only 1,000 kilometers off, it's 40 times the concentration. And not only that, that concentration that's hitting the lunar surface, it's absorbing in. And there are lots of studies on radiation hitting already irradiated surface. As it reflects back, it creates microwaves and X-rays as well. When these people are claiming that somebody was standing on the lunar surface, let's say it's just equal to what the lower band is of the Van Allen belt.
Right.
That's the environment they're in.
And the other thing I want to ask you is, let's go back over just even the last couple of thousand years, maybe 3,000 years, and given the constant bombardment of solar activity on the moon, without, of course, a magnetic field, there's going to be pockets on the moon where there's deep pockets of concentration in terms of radiation buildup, what you're talking about. Everything, it has a half-life, but how long is that half-life? And would there be an accumulation effect going back, let's say even 1,000 years, that would be considered highly dangerous today because of the cumulative effect of being bombarded by solar flares, coronal mass ejections, so on and so forth?
Well, if you're looking at half-life of some of the nuclear waste that we produce, it's 100,000 years.
There you go.
Let's say it's a lot less than that. Let's say it's only a couple of thousand years. The half-life is a couple of thousand years. So it's there for 4,000 years.
Exactly.
Right?
And that's my point.
But you have a constant bombardment and a buildup, a 4,000-year buildup.
Yes.
It's there all the time. And now you come back and here's the lunar rock samples. And they don't have a radioactive signature.
Well, isn't that interesting? And they should.
There we go. There's a rock sample.
Yeah, there's one. How's the radiation going on?
I offered him money for that.
Yeah.
Yeah.
Marcus, you're doing remarkably well with that radiation. That's amazing.
I know. Maybe it's 2,000 years old. It's all gone.
Taffy offered me a piece of petrified wood that was dug up when they were redoing the driveway, and it was absolutely gorgeous. the crystalline form inside formed around on the bands, and they're white and green and red and purple and everything all inside the thing. And my comment is who cut it? It's perfectly smooth and polished, and he said it came up out of the ground like that. It was absolutely polished, perfectly smooth. Anyway, back to the radiation. It kind of takes a while for that to sink in. It's traveling through space, the same as the Earth is.
So there's one thing I want to add to that. Jarrett White brought up the point, and I know others brought up the same point, that there are phases when the moon is protected by Earth's magnetic field. And of course, that didn't include the Apollo missions because they went up outside that phase, so the moon was not protected. That wouldn't really make a big difference because we're talking about the accumulation over thousands of years, right?
Yeah, they're basically in the same as a high-density band of our own Van Allen belts.
Yeah.
And quite possibly a much greater concentration than that.
Absolutely.
8, 10, 15, 20 times. Now you take the orbiter. How is it going to orbit? Because it's going to be within that band as well.
Yeah.
That kind of radiation messes with communications greatly. The British Interplanetary Society have been bouncing radio waves off the belts since the late 1950s. What they're doing is when they're studying it, they were trying to read whether the pulse was coming from the Earth or from the radiation out there by reading the distortion in the radio signals that are returning. But the first fact of the matter is the radio waves are bouncing off, they're not going through. And I watched it in one of the British interplanetary presentations, the guy discussing the fact that they've been doing this back from there. And it was also mentioned with our nice Canadian Payette. Yeah. There's a video out there where she did a 1-year study traveling around the northern hemisphere, studying the northern lights on it. So she's in Russia and everywhere else, talking about that and the different effects that it's having. Of course, those magnetic fields around us are not just magnetic fields, they're electromagnetic fields. And that is confirmed by what happened in 1989. The solar pulse was enough to actually push that magnetic field down across the eastern seaboard of North America, right, and gave us a blackout. I mean, it took hydro lines and just doubled or tripled the physical power of the hydro in them.
I remember that.
Our magnetic field lines are actually electromagnetic field lines.
Interesting conclusions there.
Yeah, but you see, it wouldn't be just the moon. Mars is going to be the same way.
Oh yeah, obviously.
It'll have less effect from solar flares being farther away, but you still have cosmic radiation that is going to build up on that surface continuously all the time. It doesn't have that cushion. We have 40,000 kilometers of magnetic lines out there, and the ones that get through the first lines, the lines get stronger and stronger and stronger as you come in, right until it captures them all. So that radiation is spread out across that 40,000 kilometers. When it hits a solid surface, it's going to hit it, absorb in, and it's going to be much higher concentration. I have no idea what the thickness of that layer will be. It's got to be at least 1,000 kilometers, right?
Okay, so just practically speaking, this can get so complex, and every expert, people who call themselves experts when it comes to radiation, and we use radiation in a general term. I mean, radiation, everything's radiating something. But experts who classify themselves as experts, number one, can't agree, and we were talking, Marcus and I were talking about this yesterday, can't agree on the energy flux that's in the Van Allen belts. But the thing that I want to know is, and just to make it more practical in a sense that, well, if an astronaut lands on the moon, steps off the lander onto the lunar surface, he's immediately in trouble. I mean, you're going to get a release of neutrinos, if I'm not mistaken, that's going to penetrate the spacesuit right away. I mean, it's going to be lethal. That's kind of what I'm interpreting from all of this, is that it doesn't matter what they're wearing. You're talking an accumulation of thousands of years, an accumulation of bombardment from solar activity. It's going to end any astronaut, probably within seconds, minutes anyway, put it that way.
If it's not that, the microwaves alone that are bouncing off from being the fact that it's simply lit by the sun, right, is going to create X-rays and microwaves, right? And the microwave is going to simply cook right through the suit.
Yeah. Absolutely.
By the time they touch down and hit the surface, it would probably penetrate the craft. Anybody that says that the craft is insulated from radiation and everything else, right? They simply forgot that these vehicles have windows. It's like trying to heat your house with the door wide open. It's not going to happen, right? You know?
And that might explain, too, why we've had such a high loss rate of unmanned missions. It's close to 50% over the last several decades when it comes to unmanned missions to the moon, maybe, and more so to Mars. Yeah. And I'm just wondering if that's a huge contributing factor. I mean,
I'm sure the radiation is taking them out.
Yeah, that's what I'm thinking. They
lose communication and any guidance capabilities, and it's just lost, right?
Absolutely.
But I think anything that they're claiming is being landed on there could be quite fraudulent as well, because with that much radiation and the various kinds of it and the intensity of it, it's doubtful that they could ever push a signal back. They certainly didn't have the power to push a signal back to communicate. That's obvious. But then you add on the fact that they got to get through that kind of radiation, then through the Van Allen belts. Like I said, if you look anything up from SETI, right, they're just listening to white noise, right? And they've got the most powerful pieces of equipment out there to listen to stuff.
Yeah. As I said to Marcus yesterday, when I was researching this from my first book, the amount of conflicting information that I was reading, and it was coming from scientists who are supposed to know this stuff, and it was coming from scientists not only outside but from within NASA, but that the institutions either connected or indirectly connected to NASA were coming up with different numbers as well. Yeah. And I just don't trust anything that I hear anymore coming out of NASA or the mainstream scientific community when it comes to Van Allen belts. And I think James Van Allen himself got it right in the 1950s when he said if there's ever going to be a chance of manned missions to and from the moon, they'd have to go through the North or South Pole. Am I correct in that?
Yeah, that's right.
They're assuming that there's actually a hole there.
Yeah, assuming,
Right? Like they were sending rockets up, right? And they're putting various pieces of equipment on and testing stuff. What if they were just measuring air pressure and temperature and nobody put a Geiger counter on the damn thing? The Apollo missions, nobody would have known that there was radiation out there. NASA would have faked the whole thing there and back, and then people would be wondering why it hasn't happened again, right? And here's this barrier.
Yeah, it is.
And they don't know about it. Now, here's the other thing. If there's something in space that's an absolute barrier that's going to stop us dead in our tracks that we just can't deal with, but we don't have a sensor to detect it.
No, we don't.
How do you build a sensor to detect something that you don't know is there?
Give me an example you talk about, because I think I touched on this too.
If you didn't know there was radiation, we'd never build a detector. And if you started pushing stuff up there and the rockets just blew up in the air or fell apart or whatever, right? And then they're going to build a detector. How would they know what to build and what they're trying to detect? They have no idea. You can't build it unless you already know what it is. So if it's an unknown substance out there, how are you going to build a device to detect what you don't know what it is?
I was talking about more in terms of any other object besides radiation, but you bring up a very good point, Scott. I remember talking about, I think in book one, I'm looking for something right now in book one, where mentioning there was no proximity warning sensors incorporated into the Apollo guidance computer. And that's a problem, because how would they know of anything that's coming their way, anything that might interfere or might even crash into, or, that's headed their way? Like, no way of detecting that. And it's just the whole program, when you look at it from start to finish, is hit and miss. That is the overriding theme that I have come across here in my own research and in my own writing. And I use that word hit and miss because that term hit and miss is because that's exactly what NASA was doing. They're taking a chance that they weren't going to hit a meteoroid of some kind.
At the same time, they didn't have a sensor for anybody to monitor, so they all went to bed. Actually, they all went back to the hotel, grabbed a couple of Playboy bunnies, and partied on. Because, I forget who I was talking to the other day, and they mentioned something, and I said, when they were making the Apollo movie, the simulation, They only needed to have those people on the set that they felt were important. So the two guys on the surface, and I said for each one of the missions, they just forgot about the guy in the CSM. I mean, you can't go 3 days and not talk to the guy.
Yeah.
And I said, and there's no way they can fill that information back in because they have every second of the time they're on the lunar surface, and all the audio has been accounted for every second of their journey, right?
Yeah.
The guy that's in the CSM, they didn't need him on the set, so they don't have him recorded. And that's for all 6 missions, they missed it.
Yeah, this is something I want to talk. It speaks to your point, Scott. So in book 1, I came across an email exchange between Jarrett White and physicist Dr. Jeffrey D. Reeves, and I believe it was at the Los Alamos laboratory. And so Jarrett White had sent him a couple of questions asking about, how they determine the energy flux in the Van Allen belts. And it led to this very interesting exchange, and I just want to read a quote from that. This is Dr. Jeffrey D. Reeves, a physicist. He's a specialist in this. And he says, quote, in terms of the radiation flux, he said, quote, you need a really large detector to measure greater than 15 MeV electrons. Large means heavy, so we typically don't fly detectors that massive. The measurements we do have are typically inferred from backgrounds and detectors that are intended for other purposes and for which the electron response sensitivity is not well known. And basically what he's saying is that we just don't have the equipment, we don't have the ability to launch the equipment large enough to detect what's really going on in the Van Allen belts. And this is coming from him, a physicist, right? So
and that's in today's world where we can make things very small and capable.
Exactly. So that tells me that we're getting only a minute data sets as to what the Van Allen belts are really, the intensity of the energy flux in the Van Allen belts. And they probably have some idea now, NASA, these people are not stupid. They have a really good idea, but they're hiding that. They're keeping that data classified. That's my guess on this, is they're keeping that data classified. Because if that data was to come out, and it speaks to what you've just been saying all along, there's your concrete proof right there that no manned mission is capable, at least in terms of the technology that we have right now, of traveling through and back.
If the intensity on the lunar surface is compressed into a smaller bandwidth than what the Van Allen belts are, and you're multiplying that energy in there, even unmanned aren't going to work. Right?
That's a good point.
Yeah, it's possible that they could protect against some of the radiation levels on unmanned craft. That is possible. The real problem is protecting humans.
I know, but none of the vehicles that we've seen there have any protection on them. Of the so-called probes and stuff like that, like the Surveyor 3, I mean, there is no protection on it.
Do we know that for sure? Because I haven't really looked into that aspect in great detail.
There's no protection on that vehicle.
So when the Russians sent the Lunar craft up there, did they have protection?
No, it was almost a straight copy of what the Surveyor was. Slight different design, but basically the same copy.
I mean, obviously the Russians would have been aware of some of the problems that NASA were aware of, and maybe they did something to resolve it, because if we believe that the Lunar missions were sent to the moon, they must have been able to get through this radiation and the electromagnetic parts of it as well. Obviously, the same with the Chinese. They must have known about it, because their craft have landed, we're told. That's Chang'e 4 and Chang'e 5. Both have landed. The Indian craft tried to land, the Israeli craft tried to land. So either they didn't know enough, either the Israelis or the Indians didn't know enough to protect their craft from the effects of this radiation, or they were faked as well.
That's becoming a very high possibility that everybody is trying to fake it. I find it entirely difficult to find that Russia could make an autonomous machine that could land, gather a sample, take off, and return. That is one hell of a feat.
I think it's something that we would have to consider, though. I mean, there has been many attempts, and I mentioned earlier They might have been able to at least send some missions, unmanned missions, to at least to the lunar surface. I mean, they've had a high failure rate. I don't know. You may be right. I'm not sure if I want to completely...
How do you come back into Earth's atmosphere?
I know, I agree, but I'm not
All of
completely
that.
discounting it yet. I'd have to look into it a little further. I mean, when it comes to manned missions, yeah, absolutely. The technology's not there to get through, let alone get back. But on manned missions, I'm leaving the door open a little bit until I do a little bit more research on that. The distinct possibility that we haven't had any unmanned landings on the lunar surface, but it's something I would really like to look into a little more.
In the 60s and 70s, I don't think there was the capability, and certainly not in 76 when they claimed to land one on Mars.
Yeah, no, I kind of agree with you on that.
You know,
yeah.
but I'm sure by the time we got to 2000, they must have been able to put something out there, drop a probe down, and get some kind of a reading back on it.
When I look at some of the photos of NASA that they released, that they officially released back, over 40 years ago compared to the photos they're releasing now, you wonder why some of the photos they released 40 years ago have more clarity than they do now. So I don't know. It just seems the right hand doesn't know what the left hand is doing over there. So
Well, they had better guys operating those manually operated cameras back there.
yeah.
You know? And don't
Yeah.
forget, the CBC, they were pretty good at filming stuff in the wild too, right?
Yeah.
Yep.
I just think it's important that if we're going to form an opinion, at least on something, or if I'm going to form an opinion, I just want to look into it a little more closely. I'm sort of holding out that some of the unmanned missions were successful, for now anyway, until I look a little further.
Well, you have to be optimistic, because the fact that it's possible to do some of these things is that they're continuing to do it. They're putting a hell of a lot of money into it. Eventually, if you had absolutely zero results, you'd eventually stop. I'm quite certain that they are ahead in technology that they're not releasing.
Yeah.
How far ahead?
Yeah. How far? Yeah, exactly. How far ahead?
Think of technology in the 1950s that the military were using then. I mean, they were just coming into using jet aircraft. That was the first real development around the 1950s. So if one is saying that the military are 50 years ahead in the technology they have, that would imply that by the year 2000, we would be seeing technologies that were being developed 50 years earlier.
Yeah.
Now, I don't know if there were technologies in the year 2000 that were that much different from much of what was known about 50 years earlier. It was just a natural development of it. There was no real exciting, completely different technology like anti-gravity or anything like that. That's not really appeared as a concept. Now one could say, well, it hasn't appeared because it's been kept secret. Or it hasn't appeared because it doesn't exist.
Yeah.
I mean, take your pick. It's very easy to extrapolate from something occurring in present time to something that will occur in the future. There are things we'd like to appear in the future. Anti-gravity would be very useful, but I've yet to see any actual demonstration by any nation of any anti-gravity craft that I'm aware of. Maybe they're disguised, maybe they appear as something completely different. I don't think so, because I think they would be identified. The idea that the military, whoever they are, the military-industrial complex or whatever you want to call them, are working on technologies so far in advance that we wouldn't recognize them, I think is pure PR and propaganda. The military appear to have the edge. It's part of the whole sort of Cold War activity where people were always accusing the Soviets of doing things and it turned out they never did them.
Well, the thing is any nation that obviously had technology have always used it.
Yes, exactly. They've used it as soon as it was practical to do so because it gave them an advantage.
Whether it's military or commercial, they used it.
Yeah,
Any company's going to go out there to get ahead of their competition uses their usable technology that they have available, right? They're not holding back on it. They want to take that as an advantage. You see, I think that's what the entire space race was all about. Acquiring the technology to prove that you're a superior nation, right? And if they had it, it wouldn't take so long. They'd just go, okay, you want to see my trump card?
Yeah, exactly.
right now with all the conflicts between the different countries in the world, right? If the United States had a considerable advantage in technology, they just show up in Syria and Ukraine and whatever, Afghanistan, and they'd settle the problem. It wouldn't go on for years and years and years.
Yeah, but I mean, eventually, though, that truth would get out, and people would demand to know, okay, what exactly, what technology do we really have? I mean,
No, that's what I mean.
right?
They'd show up with it and give them a little demonstration. All the rocket technology, that's what all the launches were for. That's what all the atomic bomb testing was for. There were demonstrations to show the world what they had. They didn't have to use them. They just, here, they'll do a bigger one. And then Russia, of course, blew a monster one up, right? And everybody said, hey, it's getting crazy. Let's stop this, right?